Okay, so this is sigma is variance covariance matrix of x, random vector x, n-dimensional vector. So n by n is symmetric by definition because it's a covariance matrix. So in this case, and positive positive definite, right? In the sense that if you consider this random variable, this should be non-negative, right? So and then this one should, if it is for all a, then this is positive, non-negative definite. So in that, and then we can apply spectral decomposition, so that we can write it as something like this: tau half tau prime half tau, right? So this is eigenvector, so this is actually I. So you can actually write it, write it as a sigma half, right? So you can always, from, so point is that from the given variance covariance matrix, you can always construct the square root of that covariance matrix and using spectral decomposition. So from that, so using that property, then basically you can derive a PDF, which we already saw, right, in the previous slide. So this random variable has a variance mean mu and variance sigma, variance covariance sigma, and its PDF is this form. Okay. And now the next topic is, suppose you have a transformation, linear transformation, then the random variable, the mean and variance is this form, and it's normal. So how to prove it? Well, we can use MGF. So the point is we can use, because MGF uniquely determines the density, right? I mean distribution. So the MGF of this linear transformation is this one. And then you can, second part is just it can go outside, and then same technique, we can call this as S, right? We can define S prime, and then use, this is the property of MG. We already derived the we use the form of the MGF of X is this form, right? And then basically simplify, and then we end up getting this form. So that means this is the mean part, and this is inside, quadratic term inside is the variance covariance part. So that is the MGF of this particular normal distribution. So that can be applied to derive some interesting result. One is, so actually this one is contains two results. First, for this particular decomposition, right? Then we can arbitrarily, so this is n by 1, p by 1, and this one is n minus p by 1. Okay. So and then corresponding mean and so that this is also p by 1. This is n minus p dimensional, something like that. So this is p by p, right? So the one implication is, first, the subvector the sub factor of the original random vector is also normal, and secondly, the independence is equivalent to covariance for multiple normal distribution. So regarding the second part, if and only if, so usually this part is true always, right? True always. And an interesting result is that this part is yes only under normal. Normal distribution, okay? So to prove the first part, excuse me. To prove the first part, you can see that x is just x1 is a times x, original x, where a is ip and 0. x1, x2, right? So you can actually apply the previous theorem here for this particular I and 0. So then that gives this result, because all you have to do is computing a mu and right and variance covariance a sigma a prime, which this one is mu1, this one is sigma 1. So that's it. So that's gives the proof for the first part. And second part, I guess you can basically use the second part, use MGF. So suppose this is true, so we only to show this, okay? So suppose sigma 1 2 is 0, right? So in this case, then the MGF T1 T2 is defined to be exponential T1 prime x1 plus T2 prime x2, something like that. So that that is what? That is let me write one more time. T1 prime T2 prime x1 x2, right? So we already know that the form of the MGF for multiple normal distribution, and that is exponential. Okay, so we can write it actually this way. T2 prime mu1 mu2 plus half T1 prime T2 prime, right? And then sigma 1 1 sigma 1 2 originally, right? Sigma 2 2 symmetric, and then T1 T2. So that is the MGF. But interesting part is that this one is 0. So if it's 0, then you can notice that this one becomes T1 prime mu1 plus half T1 prime sigma 1 1 T1 times T2 prime mu2 plus something like that. So then that implies independence, right? The MGF is factorized, so that implies independence. Now this is the last result, and And this is actually also quite important